Good afternoon, everyone. It's a pleasure to meet you. I am Young Cho, CFO of DEEPX. Joining me today are our founder, Logan Kim, and Tim Park, Head of Strategic Marketing. DEEPX has participated in CES for 3 consecutive years, and in that short time, I think we all witnessed that AI industry has evolved dramatically. So today, I will share our vision on where AI is headed and why DEEPX is so uniquely positioned in this landscape. Then we'll open the floor for a Q&A. Before we start, let me briefly introduce our founder, Logan Kim. After finishing his PhD from UCLA, Mr. Kim pursued his career at leading tech companies such as Apple, IBM, and Cisco. And during his time at Apple, he led development of the A11 Bionic chip, involving the world's first NPU. Furthermore, he conducted world's second AI NPU project at IBM TJ Watson in 2010. And on top of that, he has published and filed more than 100 NPU-related patents thus far. And aside from NPU development, he also accumulated extensive mass production experience at Cisco for its router chips and Apple for their AP chips. Today, Mr. Kim leads a team of top-tier professionals from global leading companies, all bringing extensive experiences in semiconductor field. We believe on-device AI trend is inevitable. Today, global devices have surpassed 50 billion, driving a massive surge in data that shows no signs of slowing down as we are heading towards 70 billion devices. And more than 40% of this data requires real-time processing. And at the same time, there are growing demand for autonomous operations, personalized service, low AI cost, strict data privacy, and reduced carbon emission. And all of these forces, technical, economic, and environmental, are converging toward one direction: strong rise of on-device AI. And as we shift toward on-device AI, it is becoming clear that data centers alone cannot meet the growing demand of AI. While the AI chip market has exploded due to strong demand in AI training and data center-friendly chips, these chips are optimized for training, not inference. And as inference demand migrates to on-device application, traditional data centers won't be able to meet this demand due to power issues, investment issues, and operational cost issues, latency issues, and privacy issues. And these bottlenecks can only be solved with purpose-built on-device AI chip. Deploying on-device AI chips across our daily lives could theoretically reduce over 80% of data traffic destined for data centers. And in doing so, on-device AI pioneers will play a pivotal role in human history, providing a virtual infrastructure that functions independently of data centers' availability or power grid readiness. And we believe DEEPX stands at the very forefront of this historic transition. So at this point, let me emphasize who we really are. DEEPX is a clear global leader in on-device NPU technology. How do we get here? First, leveraging our core tech, we have achieved industry-leading energy efficient and cost efficiency, the essential foundation for any successful on-device AI platform. Forbes reported that DEEPX holds the largest NPU patent portfolio in the world, and we are already in 50+ mass production projects, targeting a 100 billion market in 2030. And we are now developing our second generation Gen AI chip, which is capable of running AGI level models with exceptional energy and cost efficiency. And now our products, which are exclusively designed to run AI inference on the device level. For vision AI applications, our DXM1 and DXH1 products are optimized for enabling real-time intelligence for robotics, smart factories, and video systems all with exceptional energy efficiency and cost competitiveness. And this product has been in sales-ready condition as of last year. For generative AI applications, DXM2, our second generation chip, will run up to 100 billion parameter models at 10 to 30 tokens per sec speed under just 5 watts power consumption. Here's the simplest way to understand how our chips really work. You see an AI application like a smart surveillance system that detects objects instantly. Behind that result is a small piece of hardware. Our customers can easily instantly enable AI by simply inserting our product module on their existing hardware, like PCs, edge servers, and industrial computers. There is no need for GPU, no need for cloud connectivity, and no special infrastructure required. It's a plug-and-play feature. This simplicity is a key driver behind our rapid adoption across various industries. Now I'd like to explain our business model, in other words, our winning formula. Our winning formula combines the strengths of 3 industry pioneers. 1, ARM. Just as ARM captured the mobile market with their low-power CPUs, DEEPX has focused on ultra-low-power NPU technology from the very beginning. And 2, Google. Just as Google offers full-stack solutions via TPU and Gemini, DEEPX partners with leading open-source ecosystem like Baidu and Ultralytics to complete hardware to offer a complete hardware to software ecosystem, enabling true plug-and-play AI deployment. And lastly, Qualcomm. At Qualcomm's dominance in CDMA, we have built an IP fortress with over 400 patents covering and protecting our core technology. And there's an easy way to understand our ultra-low power NPU technology. We introduced so-called butter test to demonstrate our strong thermal control capability. As you can see from the video, we placed a piece of butter on multiple NPU chips, running the same AI workload. During the experiment, every chip melted the butter, except for in DEEPX. And if you visit our booth, you'll be able to touch the chip yourself and see a live demo in action. And as I briefly highlighted before, this slide introduced our open source physical AI alliance. Until now, developers who build AI applications have often worked without knowing whether their AI would actually run on devices. They develop AI applications first, then only to discover the limitations of device deployment later. So through this alliance, we are introducing a new framework that removes this uncertainty. This framework delivers state-of-the-art open source AI models already tested and verified on DEEPX processors to developers worldwide. With this approach, once developers complete application level optimization, zero effort, on-the-fly deployment becomes finally possible. Today, many edge AI projects fall into a vicious cycle. Teams write code, port to hardware, then spend close to a year just optimizing. And by the time they finish optimizing, the market has moved and model have changed. So we actually flip the sequence. We start with the deployment KPI and constraints, then evaluate hardware-aware models from the beginning, confirm data sets and training direction, then deploy on device quickly. This will maximize usability of our product and act as a strong demand creator. Here's the practical mechanism called open source physical AI alliance. Step 1, you select the model you want to use. Step 2, check the performance on the DEEPX chip. Step 3, purchase the hardware platform that meets your KPI. This is how we make on-device AI feel predictable, like buying infrastructure, not running an experiment. Now our NPU intellectual property. Ford survey says that DEEPX owns more core NPU patents than many of the global semiconductor companies, despite being a much younger company. These patents cover the fundamental architecture, data flow, memory systems, and scheduling, compiler technology that determine how efficient NPUs are built and operated. This IP fortress gives DEEPX long-term defensibility and makes our architecture extremely difficult to replicate. So now on the commercial side, in the past 3 years, more than 350 companies have tested our products. And from this extensive effort, we were able to secure more than 50 highly visible mass production projects. And we strongly believe that DEEPX is at the very forefront of on-device AI chip commercialization. Let me give you 2 examples of our mass production projects. The first is the case of Baidu. This project was built inside one of the largest AI software ecosystem called Paddle. Within this ecosystem, our customers built an AI financing agent box powered by the DXM1 chip. As you can see, this product automatically reads, analyzes, and classifies words, sentences using AI. What is truly impressive is that our chip actually replaced a 300-watt GPU, which was used in their prototype. We matched the performance and improved the latency, all consuming under just 5 watts of power. Second example is commercial robots. Commercial robots now perform perception, navigation, fully on device, without cloud dependency or expensive GPU modules. Like Baidu, Hyundai Motor Group initially considered using GPU, but decided to use our NPU instead. And the main winning factors were our exceptional energy performance efficiency and thermal control capability. And like these 2 cases, a lot of our customers are now choosing us over incumbents for our thermal and energy performance. Now, our global recognition. We won 5 CES Innovation Awards thus far, and were named a must-see booth this year, and received the Computex Innovation Award among 400 startups. EE Times named us our first product of the year, and the World Economic Forum in Davos invited DEEPX to represent the AI chip industry and lead the global agenda on AI semiconductor field. Now, I think we all know the ultimate path of AI is physical AI, but it does not sound crystal clear at first. So think of it this way. Agentic AI is the brain, planning, reasoning, deciding, and embodied intelligence is the body, robots, cameras, sensors, vehicles. Physical AI is when the brain and the body integrate tightly enough to act in the real world instantly and safely. And this is the final stage because it is where AI stops being information but becomes capability. This means AI is no longer just a machine that thinks, but it is becoming an intellectual entity that directly engages with the physical world. So in that sense, now I want to talk a little bit more about our 2nd generation chip. Today, foundation models are converging towards models below 100 billion parameters. Smaller, faster, more adaptive, while still being sufficiently smart. In other words, the AI paradigm is shifting from scaling law to efficiency law. Our DXM2 chip is perfectly designed to meet this paradigm shift. It can run 100 billion class models at 10 to 30 tokens per sec speed under 5 watts of power. This means edge devices can finally deliver true on-device generative AI experience. As I stressed out earlier, AI demand will exponentially grow, but the physical infrastructure won't be able to keep pace. It takes years to build data centers and power plants. So the question is, where can we process more AI without relying on new data centers and power plants? The answer is distributed on-device AI computer, meaning more computing at the device level. Research says by processing large models on the edge devices, we can theoretically reduce data center traffic by 80%. And this effectively allows us to build 5 times more virtual AI infrastructure in more scalable, sustainable, and affordable manner. Today, AI landscape is heavily dependent on a centralized data center model. Tomorrow, while massive frontier models will still exist in the cloud, but vast majority of operational intelligence will run at the edge level. So instead of sending 100% of data upward to the cloud, we can process most of data locally. So I want you to leave this session with this thought. While DEEPX may appear as an MPU developer on the surface, but we are actually contributing to build a new layer of AI infrastructure by enabling true on-device and physical AI experience. To recap where we are, DEEPX is not limited to a single vertical. Our first generation chip is already targeting a broad spectrum of markets, including smart mobility, industrial applications, smart devices, and professional surveillance. And looking ahead, we will aggressively expand our customer reach. With our second generation Gen AI chip, our applicable verticals will include AI PCs, robotics, auto, AI of things, and so on. And yes, our addressable market is huge. We are targeting a total addressable market of 100 billion by 2030. This actually means that billions of devices will soon require low latency, enhanced privacy, high energy efficiency, and cost-efficient solutions. Demands that only on-device AI can meet. So this concludes our brief introduction. Lastly, I want to highlight our mission statement. So our ambition is to drive the greatest transformation in human history, bringing intelligence into every corner of the physical world. Thank you very much.